Good day, Assalamualaikum and good day everyone. Today I would like to present my electrical machine design mini project which entitled to design and evaluate 9-slot 12-pole permanent magnet synchronized machine. And my name is Nurul Izzati binti Saad. This mini project required us to construct permanent magnet brushless motor by using a motor model using 9-slot and 12-pole. Okay, permanent magnet is a material where the magnetic field is generated within the material itself. A permanent magnet is considered good when it has a high magnetic field with a low mass and stable against the influence of the magnetization. And we know that permanent magnets is important in electrical industry, especially in power generation and also electrical machine. In this mini project, we want to build the motor in Opera 2D software, draw the magnetic field distribution, and also discuss the motor performance in the mid-air gap flux density, which consists of BR and BT versus the rotor position, the cogging torque, and the back EMF, EA, EB, and also EC. So this is the given motor dimension in the question, and we have a stator outside diameter, axial length, magnetic thickness, and so on. This one is the calculated parameter which we calculate throughout our mini project timeline, and this is AutoCAD drawing. This is rotor, and this is a stator. And we got the value of our shaft, which is 24 mm, inner radius of rotor yoke 30 mm. We got the magnet outer radius, which is 33 mm. And in order to get and 34 mm for the stator bore radius. In order to get the air gap for the rotor, we need to take this value and add it by 0.4, and the air gap we get is 34.4 mm. Okay, to get the air gap for the stator, we take this value which is 34.00 mm, then we minus by 0.5, then we get a 33.50 mm for our stator air gap. And for the stator outer radius, we got 60 mm, and radius of bottom slot, we got 55.5 mm. To calculate the half rotor angle, we got the formula by 360 divided by number of poles, then we get 30. The reason why we divided by 2 is because this drawing is drawn in a half drawing. Same like half stator angle, we take the value of 360 divided by number of slot, and we got the answer is 40. Then the same cases, we need to divide by 2, and the answer is 20 degree. This is our winding layout for 9-slot and 12 poles. Okay, first one, we need to calculate the slot pitch, which is 360, and which is 360 divided by number of slot, and we get 40 degree mechanical, and also we get 240 electrical. For the pole pitch calculation, we got the formula 360 divided by number of poles, then we get 30 degree mechanical and 180 degree electrical. Okay, the number of slot and pole is quite an important part in our calculation, which is from this calculation we can determine our project is we can determine our model is non-overlapping or overlapping. We got 0.75, which is below than 1.5, and our model is non-overlapping. And the last step, for the last step, we can obtain the number of slot and also number of coil per phase, which is our result is 6 slot per phase and also 3 coil per phase. Okay, the table will summarize the MMF factor for each coil. Okay, we got the phase A, F1 and 0 degree. For phase B, we got F3 and 120 degree. And for phase C, we got F2 and 240 degree. Okay, this is our winding layout for 9 slot and 12 poles. We got 9 slot and 1 slot consists of 40 degree. And this one MMF will consist of 240 degree.
My name is Nur Fatina Bila binti Nur Ashri. Right now, I will present to you about the full model of 9 slot 12 pole of PM machine. This model we draw by using Opera 2D software. Okay, as you can see from this figure, there is 9 slots and 12 poles. This is the poles. There is north and south. I will discuss about the magnetic field distribution. This is the flux density during the open circuit. As you can see, the flux density will go through from the north and through the south. Usually, if there is no stator here, they will become like this. Only just go through. But this is the stator. The magnetic field need to go through from this rotor through the air gap and through the stator go back into the rotor. Magnetic field naturally bunch together to show that there is the strongest magnetic field appears. Okay, next I will explain to you about magnetic field distribution in terms of quantum map. From this indicator, we can see that the blue one is the lowest flux density in the motor and the purple one is the highest flux density in the motor. As you can see from this figure, most of this part is the least flux density, while this part is average. There's no purple color because the flux density is not achieved until 1.35. The B saturated for this motor is 1.95. So, if the flux appears in the motor is not achieved until 1.65 Tesla, that means this motor is under design. Means 9 slot and 12 pole is not suitable to design as a PM motor. We can see the magnetic field distribution in terms of vector field. The previous one is contour field. Okay, this is the full model for the motor in the vector field. Then we zoom out one pole to show you how the vector field go through in this motor. Same as the magnetic flux, we can see the vector is go through from the north and pass to the air gap, go through the stator and go back into the rotor. The flux line will separately in two parts. This one will go to the right part and this one will go to the left parts. And the flux linkage will changing as the rotation of the motor change. Next, I will discuss about the motor performance. First, I will discuss about the mid-air gap flux density. There's two graphs that can be discussed for the mid-air gap flux density. The first one is BR and the second one is BT. First, we will focus about the BR. The highest BR value is 0.8 Tesla. This is the graph of mid-air gap radius vs rotor mechanical angle. As you can see, there is 360 degree, same as one complete cycle. The produced magnetic flux will travel to the stator or adjacent pole and eventually return to the respective pole. Then it will produce positive and negative magnitude in magnetic flux density. As you can see, there is a negative value and also positive value. Okay, next I will discuss about the BT. BT is the tangent aggregate magnetic flux density. The tangent flux density have reading during transitions of the radial flux density from positive region to negative regions, and at regions immediately under status slot opening is caused by the magnetic flux line that came out from the magnetic poles and come into the iron wall of status slot. As you can see from BR, the maximum value for the flux is 0.8 Tesla, while for the BT is 0.4. We can say that the BT have half of the value of the BR. Okay, next I will explain to you about the Cogent torque. This is how we calculate the frequency of Cogent torque and the possible time step in finite element. While we calculate the fixed time step, we need to put in the opera 2D and it can produce the graph that we want. Okay, as you can see, the frequency for Cogent torque is 10 degree of mechanical degree, and for the electrical degree is 24. The possible time span is 2 degree of electrical degree because it have 12 steps. We cannot take 6 and 8 because the value is too small and it's hard to simulate and it's not suitable to stimulate this model. Okay, this is the Cogent torque for 360 mechanical degree. Then we will take 10 degree from here and will be this Cogent torque graph. This Cogent torque will definitely produce output ripples, vibration and noise to the machines. The Cogent torque is varies as the rotational angle is different. The effect of the Cogent torque will reduce as the speed of the rotational increase. This torque is position dependently and periodically per revolution depend on the number of magnetic poles and the number of teeth of the stator. The highest Cogent torque for this motor is 3.5 Newton meter. Next, I will explain to you about the back EMF, EA, EB and EC. Okay. First, we need to calculate the fundamental of RMS phase back EMF of machine. Usually for fundamental, we will take N equal to 1. So from the calculation, we can get 38.773 volt. This is phase A. Phase A is the blue one. The phase B is the orange one. And the phase C is the grey one. The maximum for EA value is 45.44, same as EB and also EC. While the minimum value for the EA value is negative 45.42, same as also to EB and EC. We can see that this motor is balanced in all the three phases. As the conclusion, this mini project is successfully stimulated using Opera 2D software by using all the calculate parameters. All the results we discussed and the performance of 9 slot 12 poles permanent magnet synchronous machine can be obtained. That's all from us. Thank you.